Good morning and good afternoon, everyone. This is Krishna Sarvepalli. Uh, Before starting my presentation, great job, Steve and Steve, explaining about the embeddings and their usage and how you have solved the complexities and provided the solution. Appreciate providing the insights low level for that. I'm going to talk about how global payments has modernized their mainframe stack and migrated to the cloud. And especially, I'm going to cover one of the use case, which is a mission critical credit card authorization system and how we have handled it, how we have modernized, what AWS solutions that we have leveraged. That's what I'm going to talk about that. About myself, currently I'm working as a senior director of application engineering with the global payments, close to 18 plus years of experience and 10 plus years of financial domain experience. Uh, Pretty much done with my CDO program at Wharton, learning about new approaches, new strategies. And for global payments, I'm leading the architecture for the mainframe modernization. And I'm also taking care of how do you handle the entire architecture in terms of solving for all the work streams in a centralized manner and define the approaches, define the frameworks. That's going to help us out and reduce the repeatability for the migration journey. I have few things to cover as part of this session. We're going to talk about how the current architecture for the authorization system is there and how we consider the re-architected authorization solution. How do we solve multi-region capabilities, which is very unique and only small lot of players go for active passive mode. But how did we solve the active active with the DynamoDB solution? That's what we're going to talk about. And one more interesting thing is we're going to talk about the patterns. How do you mainframe is a beast? How do you handle transferring only fewer workloads at a time? Make sure that there is no disturbance to your existing workloads that are going in the on-prem. So strangler and integration patterns, how we have applied. And from last 2 years, we already know how evolved from the AI, Gen AI standpoint. And in fact, we have experimented how we can leverage generative AI within this mainframe modernization as well. Earlier, Aaron and Andy has covered about global payments. This is a second session that we are doing it. I'm not going to cover very detailed, but purely about global payments. It's number one issuer processor across multiple countries. We operate across the globe, close to 175, 100 plus countries. Currently, we are serving 145 countries, almost like 885 million accounts that we are holding within our database. So you can imagine how much volume that we are receiving it on a daily basis, especially for authorizations. We process close to 37 billion issuer level transactions. So the one that we are talking about right now is issuer under Global Payments Organization. Now let's try to understand how the current architecture, which was built from last 35 to 40 years and running with mainframe in the existing data centers. So anyone who swipes your credit card, or it can be an online authorization, it's going to originate the request and goes to networks, Visa, MasterCard, Amex, or we're going to interact with the client networks as well. And the request is going to reach out to one of the processors. So Global Payments is one of the processor who handles for hundreds of banks to perform the authorizations. So within this layer, we need to do a lot of processing, and we're going to reach out to, there are two types of mainframes available for us. One is low latency, high throughput HP nonstop system that handles our authorization processing. And the next one is, we call it as IBM mainframe, which is our account customer card holder. So this is where all the accounts going to get created. This is where all auths going to handle it. So there are exchanges going to happen in terms of the files, in terms of real time based on MQ. Now, what our goal as part of this digital transformation journey is, how do we take one of the system, which is our authorization system, and put it in the cloud? So just to let you know the scale, on a daily basis, it processes close to 120 to 150 million. On a monthly basis, it handles close to 3.6 plus billion odds. And at a peak, it's going to handle close to 6,000 plus authorizations that's going to handle during Thanksgiving and Cyber Monday. So how are we envisioning our transformation journey? How do we want to handle the newer platform? If you look at it from past 40 years, or in fact, next to 10 years also, we're going to run it on the mainframe because we need to migrate clients at a time. We need to come up with strategies with less discrepancy in terms of transformation. And we're going to migrate one client at a time, or we're going to onboard new clients directly in the cloud. But how are you going to sell this to the newer clients selling? What are the benefits that you're going to get out of the cloud modernization journey? If you want to look at the scale is we need to support multiple geographies. We operate in North America, we operate in Asia Pacific region, we operate in Europe region. So how do you support multiple geographies with different kinds of regulatory environments? For example, you need to handle GDPR capabilities. You need to handle maybe in North America a different compliance altogether. Every 3 months, association releases a compliance strategy that needs to be adopted a lot more quicker. And you need to handle multiple domains. First of all, what is a domain? If you are getting a card as your personal use, you want to call it as a consumer card. If you're getting through your employer, your organization, that's what you want to call it as a commercial card. And we all know about the debit card. So the system has to support for multiple domains. And one more interesting feature, which was asked by a lot of clients, is how do you provide extensibility within your architecture? So we came up with a marketplace functionality. We all know about the marketplace that AWS supports. It's pretty much similar to it. So we are supporting marketplace capability with plugin based approaches that you can easily replace with newer solutions, newer capabilities with very minimal configuration changes. And the next one is SaaS capabilities. So how do you provide self-service capabilities for any changes that you want to perform within the system? How do you handle it in real time manage? And the next one, which is very important and crucial, we all know about cloud availability aspects of it. It can be 99.99s or 59s, but how do you solve the last 0.301, 0.501? How do you provide the solution with the multi-region active-active strategy? How do you provide high available solution? How do you come up with an auto scaling for burst capacity? And the last one, which plays a crucial role, is security, which is a hot topic for anyone who is migrating to the cloud, especially for financial world. How do you make sure your PCI and PII data is handled with proper guardrails, follows the compliance needed by your info security, and it adopts to the encryption standards needed for the PII data? All those are embedded or considered as part of our platform goal. So there's a high-level architecture that we are depicting here. So the cloud authorization, I'll just start from the left side. You want to receive a request from associations. You'll have a front funnel that takes care of all the common functionalities. Probably we need to do, let's say we need to do HSMs. You need to make sure your card is in good shape. You need to identify which client the calls are coming in. All the common functionalities will be handled within your common layer. And earlier I covered about multiple domains. How do you route the traffic to different domains? And we provide multiple value-added services within the chain. So for example, if you need to detect a fraud, we're going to interact with multiple vendors, which is based on a plugin capabilities. We do risk evaluation, whether to increase your credit limit to handle any of the changes or before approving the authorization. Again, it supports the plugin capability. And there are card controls. For example, if you want to restrict your card within a specific geographic area, how do you handle that? Those rules are managed and considered as value-added services. So once this whole flow is completed, as I mentioned earlier, we are applying a strangler pattern here. We built only half of the system in the cloud, remaining half, which is still running in the mainframe. So what are those two different points? In the morning, let's say you received authorizations. In the night or next day, you need to do the settlements. So the settlements, you want to receive it as a file, which we are still handling in the mainframe. So we need to have a mechanism how we're going to let mainframe know, hey, these are all the authorizations that we received in the morning. Can you go ahead and settle as part of the nightly processing? So all those we are leveraging MSK Kafka heavily to transfer the data and build a real-time processing. I'm going to cover more about this one. And we're going to leverage data lake. We have built a cloud oriented data lake platform where it's going to do all the reporting, extracts, analysis, monitoring, or billing. All the strategies are centralized and made it into available into one single unified data lake platform. So how did we come up with this multi-region architecture? How did we solve it? We need to establish the connectivity. So it's like a TCP connection that you're going to get it from your associations. Once you handle the connection, you're going to start on receiving the authorization messages. So what we do it is we're going to establish the connection from both the regions, purely from stateless EC2 instances, which are part of EKS. Now, how do you manage the data? The data is managed using DynamoDB. All our crucial transaction data is managed with DynamoDB. So we did multiple POCs. For example, how do we leverage Oracle? How do we leverage RDS? Other instances, how do we leverage DynamoDB? And finally, based on certain use cases or certain requirements, let's say one of them is low latency requirement, low latency, high throughput, and a global table replication strategy. How do you replicate the data? Because at the persistence level, if you lose a region, how do you make sure that you are able to sustain odds in the second region? So, and again, the architecture supports in plugin and extensibility. For example, we leverage Oracle RDS to handle our configuration management, which is a cached-oriented solution again. And we leverage DynamoDB to handle any of the transaction-oriented data. And you see the AWS KMS there, which we leverage it for our data tokenization and data encryption strategies. So at the persistence level, all the card numbers, all the PII data, everything follows a guidelines managed by our InfoSec, and we store the data with encryption only. And finally, our MSK Kafka. MSK Kafka plays a crucial role for any asynchronous communication. Once the auths are performed, we don't want to introduce any latency. MSK Kafka plays a crucial role in handling communication to the on-prem solutions. Now coming on to our integration patterns. So as part of the journey, we have integrated only the authorization platform in the cloud. Our settlements are still running in the mainframe. So now if you take one use case, let's say on a daily basis, you processed 100 million authorizations. What our goal is, after processing it, how do you make the data available to the mainframe? Again, you need to come up with a resiliency strategy. You need to build a reconciliation strategy. That's the approach. What we go with is, as part of real time, we call that as a real time log, make it available over the direct connect. We're going to make that information available to the mainframe. At the end of the day, we're going to go with all this information, again, stored in Oracle. We're going to generate a batch file. We leverage currently Airflow and EMR for that. Generate a batch file, make it into S3, and we have a interim solution, connect direct integrated solution, which is what actually transferring those files and make it into mainframe. So now by the time the settlement files comes into the picture, your recon is also performed, because morning you are receiving in real time. In the evening, you're receiving it as a batch file. All the recons will be taken care. Any missed records, any failed records, all will be consolidated and made it available. By the time your settlement going to start and process it, you'll have all the odds happen. So if you look at this architecture, it's very different in and applying multiple strategies here. As part of the strangle pattern, we put only the authorization system in the cloud. We are still running our actual mainframe, the core data, all of them are still sitting in the mainframe. So how do you maintain those new accounts that are available here and make it on the other side? So we have data integration patterns, data sync patterns, CDC patterns that are built into it to make the data available on the cloud as well. So as part of our next release, our goal is how we're going to dissect this mainframe piece by piece and make it into the cloud, similar to what we did and what the strategies that we have applied for authorizations platform. Now let's move on to one more interesting topic. The question comes, now we have modernized, we have authorizations running in the cloud, which supports high availability, multi-region, scalability, auto-scaling capabilities, low latency requirements. All these things are solved for it. Now, from last 35 years, you have a solution which is running in the on-prem. How do you make sure that the business logic that was there, which was built from last 35 years, is exactly similar to what we have built in the cloud? So how do you do the parallel testing aspects of it? Or how do we run the regression that was running earlier in the existing world? How do you take it and make it available in the new world? And how do you support the new code releases? For example, you fix some things, you are handling quarterly compliance management, all these use cases, how do you support it? So what we came up with an approach is, we already have close to 3,600 scenarios that we have prepared. This project was started almost like 2.5 years back. Everything was built manually, and later we retrofitted it. How are we going to leverage AI-based solution, SageMaker-based approaches, embeddings-based solution, PG vector-based approaches? All these things, we did a lot of experiment. How are we going to leverage it and come up with an approach that provides a direction for any of the failures? So when the first V1 was released and put it into production, now we want to release a V2 version. How do we make sure that all the failures that's going to come into the system, or you are forced to run the regression testing, you need to figure out what are those failures, you need to allocate the resources. How do you reduce that human power and make it into a generative AI solution that provides the recommendation directly, so that we know exactly how to fix it? Okay, so that's what the approach that we came up with it. So what we did was, as part of our regression test, if there are any failures that occurred, it's going to invoke a Lambda function. That Lambda function going to invoke a model, and the model generates the embedding model that generates the corresponding embeddings. We take those embeddings and validate that with the stored values or the recommendations that was already populated earlier. So it's going to look into the Postgres database, which is our PG vector database, and it's going to identify the distance between whatever the embeddings that are generated versus whatever the recommendations that were earlier provided. Now, once those recommendations were provided, you want to take those recommendations. It can return 3 or 4, or it might return only one recommendation. You're going to take those recommendations along with the embeddings that were generated. You're going to submit to the large language model, which will going to let you know the corresponding recommendation, that the developers can leverage it to fix the problem a lot more efficiently. So as part of it, there are definitely data creation patterns or recommendations that you need to come up with it. The failures that you need to identify it. For example, whether it is a system failure, whether it is an integration failure, whether it is an actual bug that was introduced. We dissected all these things and created categories out of it. Now loading the data into the vector.db with enough information saying what would be your recommendation out of it, and leverage that information and make it available as part of our report generation. So after you execute this 3,600 test cases, it's going to produce whether everything is in good shape. Results, some test cases are failed. Along with the failure, it provides the recommendation. So which is the next step of how do you fix the problem a lot more efficiently. So this has tremendously helped us out to identify the issues and improve the developer productivity in resolving those issues. That's all pretty much from my side. Anybody who is interested in contacting, please leverage my profile in LinkedIn, and you can reach out to me for any questions and clarifications. Thank you.